Hi, in this instructional video, I'm going to show you how to organize your field collected water quality data for entry into a spreadsheet, which can then be uploaded into the Safe Water Optimization tool for analysis. We can access the tool via the main web page for the SWOT at safeh2o.app via the link down here. If you already have an account with the SWOT and login credentials, then you can log into the page. If not, you can access the registration page, fill out your details, and someone will get back to you with credentials for login. For the purposes of this video, I'm going to use my login credentials. And now we can see that the top ribbon of the page here is populated with links to various parts of the site. We'll be looking for now at some of the instructions here. Just to give an overview, you've got at the top a link for the field data collection protocol. This you should already have had a look at prior to the collection of data in the field. There's a field data collection form or a link to the form here if your teams are using hard copy data collection. Remember that if teams are using a digital data collection method like Kobo Collect, they can receive all the information and help from our team. And in fact, that makes data entry into the SWOT much easier, as the data will already be organized in the correct format. But for now, we're going to show how to do manual data entry into a spreadsheet, which can then be uploaded. So we can access the data input template via this link here. The file downloads. I'm going to open it. Opens in Excel. So we have an Excel workbook, and in that workbook we have two worksheets. One of them is the actual data entry template itself, and the other gives some instructions as to how to carry out the data entry. It's this table here that we will quickly go through just to make you familiar with the different types of data required for the SWOT, some of their units and formatting, and any other requirements. So in the leftmost column here, we have a description of the field code. These correspond exactly with the headings of the columns in the actual spreadsheet, data spreadsheet itself. The first one is date time. That's the date and time of the measurements made at the point of distribution. So TS, tap stand here. Then we have the FRC, measured in milligrams per liter. This again is the FRC that's measured at the point of distribution. We have two more water quality measurements which are ideal for the SWOT. Those also should be measured at the point of distribution. One of them is the water temperature in degrees centigrade, and the other is the conductivity in microsiemens per centimeter. If teams need any help at all with how to measure, or the most ideal way to measure these parameters in the field, then full support, as ever, is available from the SWOT team. Then the last two are measurements that would be made at the household level, the follow-up measurements after a certain period of time, depending on how the teams are organized. Again, we have the date, time. This is a combined format. I will explain that format in more detail. And of course, the free residual chlorine in milligrams per liter. So the most complicated part of this is the date and time format. So the SWOT requires a single cell entry for the date and time. For one paired sample, that will be the date and time at the point of distribution, and then again follow up at the household. We can see from this table here the organization of that, or the format of that of that data should be year, 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 month, month, day, day, and then uppercase T and the time with a colon separating the hours and the minutes. This seems easy enough. The only problem comes if you have your data already organized, say with the date in one column. Let's show an example here, and the time in another column, and you want to combine these two into one column. We can call this date time here. The problem sometimes in Excel, and this doesn't always happen, is that you enter in the date here and the format of that cell changes. You want to maintain a general format for these, so I can change all of that column. They need to be maintained as a general format. So as you can see, this one has changed. We try with the time. This one too has changed. There's a very easy way to deal with this. I will delete these and show you. Let's select those two, make sure it's a general format. If we put a small apostrophe in front of whatever we write here, then you can see the format remains the same. It'll be exactly the same for the time as well. So there we have it. That's exactly how we want it, except now we want to combine the two and put the T between them. So you can imagine that you have all of your data collected in the field. Someone might have entered it into a spreadsheet already, but they've separated the columns, or you want to make the data entry into this form easier. So if someone sits down and goes through, it means they can also copy dates in the columns, etc. So to combine those two, very simple. We use a formula. So in Excel, that's equals the contents of this column. And then we go and uppercase T and the contents of the time column. And that should also have maintained the general format. That then, of course, can be copied and pasted into the column there. And we can see as well, we can imagine we have 20 plus rows of data here. We already have a formula. We can also copy down this formula, and it would create the date time format from the two columns here. So it's very simple and helps you to create the date time format that you need for the SWOT. So now I've shown that, I'm going to clear all the contents, go back to here, just to remind us again exactly what data is required. So we have the 4 measurements from the point of distribution: the date, time, the free residual chlorine, water temperature, and the conductivity. The last column here shows you whether that data is required or not. Quite obviously, the date, time, and the free residual chlorine, for the purposes of the SWOT, are required data. The water temperature and conductivity are not obligatory, but they are ideal. And it's suggested that if they're not available, or they're not measurements that are made routinely with the free residual chlorine measurements, then you can use a figure that comes from a routine water quality analysis that might have been done by field teams or in the lab. And then, of course, the last two will be the follow-up measurements, typically at the household after a period of time. Again, of course, date, time, and the free residual chlorine in milligrams per liter. There are examples of the data here, and that's how they should be. That's how they should look prior to the entry into the spreadsheet here. So only the last thing, once this spreadsheet is populated, it will look like This one, I take a data set that was collected. This is a spreadsheet with data collected for the purposes of the SWOT from a site in Kutupalong, refugee settlement, Bangladesh. We have, I think, well over 2,000 measurements here. As you can see, organized in exactly the way that we were talking about. The only additional thing with this data is that it came from digital method collection using Kobo Collect. So Kobo Collect automatically adds the time difference from UTC time onto the data. So Bangladesh is 6 hours ahead of UTC, and so it's included. That is not necessary. The SWOT will only use that date and time in the format we spoke about before. So as you can see with this, we have saved that data, SWOT, test data set, BGD for Bangladesh. That's what you need to make sure you do when you have filled out this spreadsheet. You need to save it, and save it with a name that you can easily recognize, so you make sure to upload into the SWOT the correct data set. And it needs to be saved in XLS or XLSX format, or even CSV file format will work as well. Those are all compatible with Microsoft Excel. So that's it for this instructional video. The next one, we will show you how to upload that data set. We will be using the Bangladesh data set, how to upload that into the Safe Water Optimization tool, and then afterwards, how to retrieve the results. All of those features are available, of course, in the Safe Water Optimization tool itself. Okay, thank you very much.